Concept of linear dependence and linear independence. So these are very simple definitions. First, let us talk about linear dependence. So linear dependence is considered to be talked about of a set of vectors or a set of functions. So let's talk about a set of vectors. A set of vectors v1, v2, say up till vk is said to be linearly independent if first we talk about linear dependence. So the set of vectors v1 to vk is said to be linearly dependent if the linear combination of say v1 up till vk is equal to 0. What do I mean by that? That means for any given coefficient set a1 v1 plus a2 v2 plus ak vk, this sum here has to be equal to 0 without the coefficients a2 up till ak equal to 0. So not all coefficients equal to 0. What does this mean? This means that one of a1, a2, ak or several of a1, a2, ak might be non-zero, but the sum right here, the linear combination, is turning out to be 0. So it's very important. A corollary here is that set of vectors containing the null vector is always linearly dependent. What do I mean by that? It's very important to understand what I mean by this here. Say we have a set of vectors v1, v2 and up till vk, also including the 0 vector. So what I'll do, I will do a1 v1 plus a2 v2 plus up until ak vk and plus let's say gamma times the 0 vector is equal to 0. Now say this quantity is non-zero. Say this quantity is non-zero. So here all these coefficients are not 0. But what will I do? I will make this particular coefficient right here. I'll make this coefficient non-zero. And even if all of a1, a2 up till ak are 0, this quantity then becomes 0. If all of ai's are 0, then this quantity becomes 0. But gamma is non-negative, non-zero actually. Gamma is non-zero. Since gamma is non-zero, the set is obviously linearly dependent. This is very important corollary. Now let's come to the second definition of linear independence. What is this linear independence that we are talking about? Linear independence is very analogous to dependence. So here what we essentially say is that a1, a2, a1 v1 plus a2 v2 up till ak vk is non-zero. Or an alternate definition is that if, this is much more important, mathematically important definition is that if this quantity is 0, then this implies that all ai's are 0. Then all ai's are 0. So these coefficients, all of them are 0 if this quantity is 0. Or otherwise, the alternate definition is this, that this sum is just not 0. So mathematically speaking, this thing is algebraically important because it helps us to prove some properties of linear algebra. This is very important.